So let's start and let's talk about the feature flag. Today I would like to share with you how we make our releases more safe and less stressful with feature flags. You all know it. It's Friday evening, you have a feature, you tested it, it's ready, you deploy it, everything looks good, you're already thinking about your weekend plans. And then as the deploy progresses, you start to see some errors. Better? Okay. You're still fine, but you start to be concerned. And then you start to see some alerts, and your monitors fire, and you know it. You caused an incident. You're panicking. Most of the team, they're off already for the weekend, and the rollback will take at least half an hour, 40 minutes. And in the middle of that chaos, imagine that you could have a magic wand with which you could stop this in just a couple of seconds. As it turns out, you can have this magic wand, and it's a feature flag. If the risky changes are guarded by a feature flag, you can switch that feature flag off in a couple of seconds, and then you can proceed with your rollout or with fixing the bug which you introduced. Can a feature flag save you from everything? Definitely not. It can't really help you with migrations or transitions or some other issues, but they can spare you a lot of troubles. So today, I'll talk about feature flags in general, then how we use them to ship a feature called default setup in code scanning, and we will finish by talking about feature flags at scale. So now I have a couple of questions for you. Who knows what the feature flags are? Okay, nice. Who did already use feature flags? And who is using them right now in their job? Okay, still some people, very nice. And who knows Ruby? There are some Ruby people. Good. Okay, let's continue. So the main advantages are being able to enable the feature flag in a second and decouple the shipping of your code from shipping the feature. We can enable the feature flags by either actors. We do this for testing. For example, if I'm working on a new feature, I can enable it just for my own repository and see how the changes work there. We can ship them for groups. We often ship most of the features at GitHub first to the staff. We call this staff ship. So all the people working there can use the new feature and give us feedback. You also can enable feature flag by percentage, and it's either percentage of requests or percentage of users. What actually are feature flags? In the most simple way, it's just an if statement, which can branch the old and the new behavior. So let's look at a couple of examples, and this is a pseudocode, right? Ruby pseudocode. We know that developers like pets, so let's say that GitHub would like to introduce a new feature, and they would like to show a pet profile next to the user profile. But don't wait for this feature. It's just for the presentation. And the most basic code could look, okay, if the pet profile is enabled for that user, we want to show the combined profile. If not, we show the regular profile. Again, in the simplest form, we can have a method define something like this. So for GitHub Flipper, we check if this feature flag is enabled for the user. We often also work with repositories, so we check which features are enabled for specific repositories. We use gem called Flipper, and it's a gem for Ruby, but I know that there are, in different languages and frameworks, there are different solutions for this. We also use our own tooling, which is coupled with Flipper to work that for GitHub. And we also sometimes have feature flag, which is disabled. So before we had the pet profile enabled, and now we have a new feature flag, and it's called pet profile disabled. Why do we want to do that, right? It can be that we No. Okay. So, do you still hear me? Okay, very good. So we use disable feature flags if we enable the feature flag for a big group, for example, we stuff ship it, or we enable it for specific customers. But there's a specific case. There's a specific repository, specific company, specific user, or maybe it's a repository which is causing problems. And for this one, you can disable that feature flag. So that's why we have this return clause at the beginning. So the disable feature flag takes precedence over the enable one. And if you won't hear me well, just tell me, and I can take a hand mic. Okay, so I was talking a lot about safe deploys, but what does that mean? A big part of safe deploys is decoupling of shipping the code and shipping the features. So when we put a risky change behind the feature flag, we can still decide when and to whom to enable it after we deploy the change. We can also start testing it in production. If things go wrong, we can disable the feature flag in seconds and take enough time to research the bug, write the fix, and deploy it. Another huge advantage is the ability to ship features incrementally. So we are not creating these huge feature branches where all the new code has to go, and then we would have to fix conflicts always. So we try to ship small PRs, because those are easier to review, they're also easier to test. And that's why we often aim for self-contained changes. If the same set of changes is under the same feature flag, we can ship them to production incrementally. With smaller PRs, the chance of breaking something is also smaller. And if we do, it's easier to find the culprit. We can catch potential problems in production early by always testing the small part of the feature. And also, we often have a bunch of people working on the same feature using the same feature flag. So like this, they can ship their changes independently, and they can test their changes independently of others. So let's look at some good practice on how to use those feature flags. We want to guard all the new behavior. We don't necessarily want to put a feature flag check before or around all the new code. So if we have a new method, which is called pet details, then we can add a return statement just at the beginning of that method. And then all the other methods, like method A and B and some other method, they don't need the feature flag anymore because they will be never called. And like this, it's not only more performant because you run the feature flag just once, but it's also easier to understand the code and you don't populate your code with those feature flag checks. When we are adding a new behavior to an old method, for example, like this, we have a profile hash where we are creating a hash for a user. And if the feature flag of pet profile is enabled, we want to add pet hash there, right? So again, the first part runs, and then we check the feature flag. If it's on, we create pet hash and merge it with the profile hash, and we always return the profile hash. So again, this middle part of the code is totally protected by the feature flag. But if we look at a similar solution, we also create the profile hash and then we create the pet hash. But in this case, we are only guarding the merging of the hash. And this is not really ideal. Why? Yes. Exactly, because even if we don't merge that pet hash, we will run that code. And maybe we didn't run our migration, so the users don't have their pets yet. Or maybe we, I don't know, we didn't fill something. Maybe we did a mistake. And we can't really switch that off with a feature flag now. The code will run and it may break. So that's why this solution is preferred to the other one. If we are in a view. So HTML, ERB is a templating language for Ruby. And let's say that we have this big view. And if we want to change it on many places, right? We want to change a different profile picture. We want to add something to a description. We want to add some different buttons. So if we would do it on each of those places, again, it could happen that it will be harder to understand because you have to go in and check all of those. So in those cases, it's often more adventurous to create two separate branches. Even though you will have to copy over some part of the code, it's still easier to understand. Okay, this is the new version, this is the old version. But this also goes closely to how long those feature flags lives, but we'll talk about that later. So let's say we have many components and places where we need to change the behavior based on our feature flag. And again, up there, there's our component, and down there, it's our RB file where we have methods which are generating data for that view component. We could check the feature flag on both those places, and it's not necessarily bad, and usually nothing happens. But we can do it better, and we can create a helper method where we check the feature flag just once and save it. So this part, the add enabled, is memoizing the method, and then we can use it in the same file or also in a view. So we are reducing the number of calls, number of times when we need to check if the feature flag is on or off. So when to use a feature flag? We aim to use feature flags for all new features to be able to test them, decide for whom and when we want to release them. We also use them for experiments or prototypes, which are not meant to be shipped to public. And we also use them for risky changes or even for risky bug fixes, including changes potentially influencing performance. And when do we not use them? We often don't use feature flags when there are small, non-risky changes, when we can fully test them, for example, if we are changing a copy. Bug fixes, which we can see right away, if they, we can test right away and we are confident that they won't break anything, or small changes. This doesn't mean you can't use feature flag, it's more on what you decide, and this is our strategy. And here's a set of little tips how to keep the feature flag manageable and nice to work with. First thing is to use obvious test names, because you want to always cover the behavior with feature flag on and with feature flag off. So when we write these tests, we make it clear what is this test testing without the person needing to read line by line and understanding what the test is about. And this also helps with the cleanup, because once you're cleaning the feature flag, you know that you can just delete the tests which are for feature flag off, and then you just rename those and keep for feature flag on. As we saw, you can memorize the feature flag and increase the performance by sparing the calls. You can also make clear which feature flags are related to which team or project. So as I said, I'm part of the code scanning team, so all our feature flags are pre-named code scanning, and then, for example, default setup or autofix, which is name of the feature, and then name of part of that feature. So there are hundreds of feature flags right now used at GitHub, and when we need to look through them, it's easier to find them. And also, if someone has a problem with that feature flag, they know whom to call. When testing your new feature, it's good to, so if you have a the issue or ticket you're working on, it's good to write down, okay, these are the feature flags you need to switch on in order to test this behavior properly. And you may even include the instructions how to do that. And lastly, you want to clean them. What I heard from teams in the various companies when we talked about feature flag was like, it's a good idea, but it creates a lot of complexity because the feature flags just stay there in the code and then we have many branches. And I can see that happening, but the problem is that you just need to clean them. We aim for, after fully shipping the feature, we keep feature flags for small things around for a couple of days, and for big features it's 1 or 2 weeks usually. We also have a long-running feature flags for things we want to test longer or we may want to change. But in general, the idea is that part of the development is also the cleanup. So we talked about feature flags in general, and now let's talk about how we shipped the default setup using feature flags. As I said, I'm part of the code scanning team, and code scanning analyzes the code for vulnerabilities. And we are creating alerts on a pull request or shown on for the whole code base. The alert can look something like this. So we have a code, we find some vulnerability, and we create an alert. By the way, it's free for public repository, so if you're on a GitHub, you can also try that. Initially, in order to be able to set up code scanning, you needed to commit a file, something like this. It's not super complicated if you would read through it, but it is quite some bunch of text, and you know, if you're not sure what all those things mean, it can be scary to commit that because you don't know what you're doing. So having this set up was a blocker for many of our customers, especially for those who weren't developers, but they also wanted to set up code scanning. So the whole point of this feature was to enable setting up code scanning through the UI with some predefined configurations. That's why it's called the default setup. Our solution looked something like this, that now in the settings you can select if you want to use default setup, that's the UI version, or the advanced setup, that's the version which you saw before with the YAML file. The feature evolved and we were adding more and more configuration. I think this is like close to how it looks today. So right now you see what languages it will use, or for which languages it will run the analysis. You can select query suite, and then you also see on which events the code scanning will run, so on push and pull requests, and then how often. Right now you can also configure, so you can select or deselect the languages, you can decide which query, and then enable it. So let's look how we did get there with the help of feature flags. To start, we decided to build an internal API to help us with the testing. So our first part of the work, and also our first feature flag, was an internal API. Then we introduced the feature flag to our backend, to our monolith. So we have a big Rails monolith and then microservices. But because this was a new feature, we didn't have to add that feature flag to the microservice because those tables and those endpoints were not used if they weren't called from a monolith. So it was enough for us to have the feature flag just in the monolith initially. And this made it, again, simpler. We planned at the beginning which work can run in parallel and which tasks needs to be consecutive. And so at the beginning, we ended up with 3 feature flags: the internal API, the UI, but that also covered the backend changes, which made the UI work, and then protected branches, because this was also part of the feature, but could be shipped separately. By having a separate feature flag, so the protected branches was depending on the UI feature flag, but we could decouple it. So we could decide later if we want to ship them separately or together. And then let's talk about testing. So as I mentioned, we always write tests for feature flag on and off. Then most of our team, or all of our team right now, is using code spaces. It's like it's replacing the local setup because there are many things changing. We also need actions. We need to run our microservice, and the code spaces are making this easier. So this is equivalent to a local testing, right? If I make a change and I want to see the UI, I can change it locally or in the code spaces. We have a bunch of CIs, and some of them are also concerned with the feature flags. Maybe you're thinking, okay, now we are talking about 1 or 3, but what happens if we have tens of the feature flags? Don't they interfere with each other? And the truth is that sometimes they do. And for that, we have a CI check which runs all the feature flags against each other. So they run all the feature flags enabled and disabled. And if there's a problem, we again see it before we even ship the code, before we open the pull request. Then we use something called Review Lab. Who did hear about Review Lab? That's a question. If you heard about Review Lab, raise your hands. Okay, maybe you heard about it under some different name. So Review Lab is a deploy of your own branch, but with a production code. So before you deploy the code in a normal way, you can ask for your own specific version of the environment, which is deployed with your PR, but it's not merged to main. And on a specific address, you can then change your changes, test your changes with the real data. So this is like the last check before we really go and deploy the changes. During the deploy, we have something called canary, which is the part of the request which already have the new code. So even as we roll out the changes, our deploy takes around 40 to 50 minutes because we have like different gates and different stages. And part of it is that we deploy first to 2% and later to 20% of the users or requests. And already during that time, you can switch it on and off, and you can test your changes in canary. So that means before the deploy is finished, you can see it in a production and interact with it. And then lastly, once it's deployed, again, you want to make sure that everything works as expected. Do we do all these steps all the time? No. But for the big changes, we definitely do. For the changes when we want to be extra safe, we also do them. And I mean, we always do the test. We always run the CI. Local testing depends how easy or difficult it is to set up the data. So sometimes we skip that one, and then we do Review Lab testing. And that brings us to shipping the feature. First, we usually, as I mentioned, enable the feature flag just to our team so that we can play around with it. When the feature is ready or close to ready, we staff ship it. That means all the people at GitHub, all the employees at GitHub will get the feature flag enabled. And this is a big advantage of dogfooding, so using your own product for work. Because like this, we can catch many bugs and we can collect feedback earlier, even before we start the private beta. Which takes us to the third group. And so, again, for selected feature, we do private beta. We select individual customers. We enable feature flag just for them. And then often we also run, or our product team or lead engineers conduct interviews with them. We are finally going to a public beta, and some of the features are shipped directly. And if we, again, want to be super sure, we can do so-called dark ship. And Dart ship is, again, shipping to a specified percentage of requests or users. So the users don't even know necessarily about it, but we can compare on our dashboards how the new change is behaving. And lastly, we are coming to GA. That means general availability, when we enable feature flag to 100% on all the environments. We couldn't do this confidentially without good observability tools in place. So before we ship it, we need to think, okay, how can we see that this change works as expected? And then during the deploy, we have monitors and dashboards to monitor and see if everything goes well. Again, after the deploy, after some time, we want to check that everything works as expected. We shipped the default setup on 9th of January 2023, and that increased the adoption of code scanning significantly, as it enabled developers to set up code scanning with a couple of clicks, without the complexity of a YAML file. And now it's time for cleanup. So when everything goes well, we aim to remove the feature flag in a couple of days for small features or a couple of weeks for longer features. It's also possible to prepare the cleanup branch even before you ship the feature flag. So if you don't think there will be a lot of new changes coming, you can either place comments in your code if there's a tricky place and you want to be sure that you don't forget it in the 2 weeks when you'll be cleaning it, or you can even prepare the cleanup feature flag and just resolve the conflicts when the time comes. We also write this as a task, which is part of the project, so it's not forgotten. You usually want to remove the feature flag from the code, from the tests, and from the tooling. And when I was preparing the talk, I even found the script which does that automatically, which creates this PR for you. I didn't test it yet, though. Okay, so when everything works, we can remove our feature flags. But what's next? That was just the start. We shipped the product, but it was an MVP. The goal was to add more and more configurability. So over the time, we added the possibility to select the query suite. We created a public API for this feature. We were adding support for different languages. And people were able to select the languages. Then we added setup on organizational level, detecting the language change automatically, and also giving the people possibility to decide on the schedule of the scans. And it's pretty much for all of those, there was a different feature flags. We also had a case when we needed to work closely with a different team for that organizational settings, because it's owned by someone else. And so we decided to go with 2 separate feature flags. They were having a UI one, and we were working on the API changes. The API changes were dependent on their feature flag, because with the UI they were also doing the backend changes so that it all works. But by having this separated, we decreased the risk that the UI work would slow down the shipping of the main feature, the possibility to set up the organizational default setup. At the end, we did ship them together, but it was because we had everything ready, but we didn't have to. So it gave us way more time to prepare anything. And these are all different change logs, how default setup was changing over the time. Yes, so we were talking that we are using feature flags in the monolith and also in our microservice. It enabled us to work on the same thing across different teams, and we use different feature flags for different parts of the feature. We use them to add configurability. But GitHub is special because of its scale. There are 2 big issues with running feature flags at scale, and that's the performance and how should the system scale. When I looked this morning on our repository page, we had 128 features on that one page, and 76 of them were enabled. We were preloading 134 of those features in 9.5 milliseconds, and we were doing 425 feature-enabled calls in 44 milliseconds. When we started, the feature flags worked just in the monolith. So if a microservice needed to check if a feature is enabled or not, the microservice had to call the monolith, get the answer, and then decide what it do. And this it wasn't optimal. So feature flags became a separate service, which can be called by not just our Rails monolith, but also by our other services. And like this, we can use them from different services for different languages too. The input-output calls are expensive, and we don't want to slow our application just because we are doing feature flags. So to address this, we implemented caching, and we can also specify which feature flags should be preloaded in which views. Shipping a GitHub Actions was special, because this was a feature which was being enabled for tens of thousands of customers at the same time. It was the biggest feature in this case until that point. And so slowly, over the time, as we enabled the feature flags for more and more users, the page was becoming slower and slower, and at some point, it just caused an incident, because there were too many feature flag checks. So what did we use from that? We started to use something called big features. And big feature is basically a feature flag which has many actors. There's not a clear cutoff, but if you are enabling a feature flag for hundreds of people, then it would be a feature flag, a big feature. Now let's talk about gates. The way how Flipper, the Ruby gem which we use, stores information about what feature flag is enabled and for whom is by creating a gate. Do you remember all the ways how we can enable a feature flag? So we can either use a Boolean, and we can say it's enabled for everyone or not. We can enable the feature flag for individual actors, for groups of people, or percentage of users or requests. When we look at the object, this is the object of the Flipper gate, we see that the feature key is the name of the feature. The Boolean is the way how we enable it, and then the value, in this case for the Boolean, is true or false. Then we have a different gate for groups, right? So the key is groups, and the value is again the name of the group for which we want to enable it. That could be, this is the same, it's a groups feature flag, a groups gate with a different group, early access. And then we have a special gate for actors. So this is for each actor, there would be a gate, which key actors, and the value is now the ID of the user. And then we can have the same for percentage of time and percentage of requests. You get the idea. So for regular features, we are caching and querying all those gates, actor, groups, and percentages. For big features, we are caching and querying just the 3 last groups. So we are not caching and querying the individual actors, because in this case, we want to separately load specific actor and then do the check just for him and cache that result individually. This will increase the amount of reads which go through the database, and also it will increase the amount of keys which we store in Memcache, but it will keep the individual keys smaller, so it's faster to iterate over them. And that makes the whole lookup faster. So we want to know how our web app performs, because that's what we actually care for, right? That the people can use it, that they get good experience. That's on each page. We, as a staff, can see the amount of enabled and disabled feature flags, and also the amount of calls we are doing, how long those calls are taking, which features are preloaded and which of those features are the big features. Of course, every company has its specifics, so it's important to cherry pick what's working for you, what fits your case. But with that, that's all what I wanted to share with you, and I hope you'll have a lot of fun with feature flags. And we can stay in touch if you want to. If you have a question, there will be question round here. Then there's this community place, or you can send me a message on LinkedIn. Thank you.